Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today we have Kaiweets in the lab again. They've sent me some more meters. These meters I think came out in late summer. They're out now. You can buy them. You can find them. You can use my links, and if you do use my links right now, there's some special sales going on for the Black Friday. You know, in the U.S. we have Thanksgiving, and day after Thanksgiving is the Black Friday, the big sale day. These guys are having sales, but they're lasting. I think they started yesterday, so sorry, just getting this meter out, or just getting this review out. But they started, and they're going to go, I believe, till the end of the month. So check out the links. They also have, like, they call it the newbie discount, or I mean, I don't know, it's like a raffle or something, but you have a chance to win things, you know. So check them out. There's special sales going on and all that kind of stuff. So there's some giveaways. I don't really want to talk about exactly what they're doing because I don't have anything to do with that. I'm not sure how it works. Just check out the links. It looks like a pretty decent deal though. I mean, to start with, the prices are really good. These are new releases. They just came out. Really cool. You may have seen a video that I did. If not, I'll put the link down below. This is the Kaiweets HT112B. And this is a 6,000 count meter. Has that nice quality feel like your cell phone. It's a small cell phone, right? And it takes a couple button cell type batteries, the CR2032s, I believe. And I have replaced them since I've had the meter. But I've replaced batteries in my other meters too, so nothing really stands out yet. But they do take the smaller banana jacks, which, from what I understand, if you damage your leads, you need some new leads, Kaiweets will replace them for free. Okay, don't know that for sure, but that's what I've heard. And these things are warranted for 3 years, so that's pretty darn nice. 6,000 count meter here. This one's a 4,000 count, this new smart meter. These are all smart meters, so they're kind of automatic meters. That's cool. And they have really nice displays. This one does. I haven't powered these up yet, but I'm really interested because I think this one has some colors too. This 4,000 count, this one is like this HT112, but this one is a 10,000 count meter with some extra functions. So it's kind of like the HT112 on steroids. So really cool. Can't wait. Okay, it's called the KM601. Can't wait to put batteries in it. This one's the KM312B. So yeah. You know, one thing I wanted to mention was as far as accuracy, or you know, the tolerance of the meters. These meters, the tolerance all falls within, I think it's 0.5% for DC, which is really standard for a lot of meters in the $200 price range and down. And you know, around 0.8% for the AC range. And so the thing about them though is they have more ranges than some of the other meters, like an extra range. And that's an important thing because an auto ranging meter, sometimes you don't realize it auto ranges between, say, only 3 ranges. That doesn't give you a lot of resolution. So if they have 5 ranges, let's say, instead of 4, you know, that's better, right? You get more resolution before you jump down to that next range. So these meters have a bunch of ranges to them. When I was comparing them to some of the other meters, well, here, let me show you one. This is about $120 meter. So they have Fluke. This is the 18B plus. The 17B, you know, there's a series of these B plus meters. I don't think you can buy them in the U.S. I don't think they're meant for the U.S. market because I don't believe they come with the third-party testing. They're made in Malaysia, I think, or... So yeah, I think this meter is made in China, I believe. And it's just, nothing wrong with that, but it's just like these meters. They have the CE mark, and you know, that's a self-certification, but they don't have third-party testing. Neither do the Kaiweets. None of these meters do. This one, just because it's yellow, it's $120. 4,000 count meter, same as that. Yeah. The thing is that one is not true RMS. So when you're doing any AC voltage or AC current readings, unless it's a pure sine wave, you're not going to get an accurate reading. Okay. It's not true RMS. It blows my mind that they still sell true meters that are not true RMS. That just kills me. But anyway, there you go. Let's bring it camera over, take a close look, and let's check out these meters, okay? Oh, and by the way, I think I'm going to have one of these to give away on Thanksgiving Day, so I have to figure out how I'm going to do that. Let me know what you think. Anybody wants one of these real bad, let me know. Maybe that's how I'll choose. So, alright, especially if you're a student in the U.S. Now, if you're outside the U.S., I've spent a lot of money shipping meters, and so that's kind of a drawback there. I think if someone outside the U.S. wants, I'm going to give some freebies away on Black Friday. I got to figure out what I'm going to give away, but I got some meters I'm going to give away, and I think if I ship outside the U.S., I'm going to have to ask for shipping. So otherwise, in the U.S., I'll pay for that. And alright guys, let's do this video. Alright guys, so let's just start off with looking at that HT112B just real quick, just so we can compare these things. So in case you've seen the review on this, if you haven't, links down below. Flashlight on the back, and it has that silicon case I'm talking about. So nice feel to it. Automatic meter, smart meter like these, okay? So if you haven't seen that one, and then it comes with the leads, much nicer than another brand I can tell you about. I mean, they do come with the small banana jacks, are not standard, so that's one thing to be aware of when you're buying extra leads for those. They have the safety caps on these. So okay, so there we go. That's mid $30 price range. Here, let's start off with its kind of new guy. Now this one here has that appearance, right, of the other one, but it doesn't have that silicon case. This is what this one looks like, you know, but this one's just a plastic, so it does have more of a plastic. It's real lightweight. There's no batteries in it yet. It does take 2 AA's, which looks like they're in the box. Okay, so it does take 2 batteries. That'll add some weight to it. And it looks like you can see they're the standard lead size, so that's nice that they've done that, because it makes it much easier to use what you already have or to find new ones. But it also has a flashlight, a little bit different lens, but very similar. And yeah, anyway, so 4,000 count. We're going to put batteries in it so we can look at it. And the leads they actually feel very similar to those. They feel pretty soft. Here, let's just pull them out of the bag. And you see how they unravel, and they kind of don't hold their shape. They kind of straighten right out, unlike another brand I can talk about. So the TO72s that you guys might be aware of that I really dislike. Sure, everybody dislikes them, but yeah. So hard plastic up here, the gray is softer, and it has the tension relief here. I mean, not the highest quality test leads for sure, but not bad. I mean, for probably under $30, you get a true RMS meter, and it's a smart meter. So we'll figure out, we'll take a look to see what that's all about. And here, let's just get the box out of the way. Okay, again, so a nice size large manual, but you notice the similarities, same kind of soft hard case, just larger. It's like the big brother, and it has some weight to it, has some girth. There's the light, a little more similar to this one. You know, it's kind of grippy. Has the flashlight button here. It has the auto power off button here. So that just makes it real easy versus trying to memorize which button to hold down when you hit the on key. And it has the silicon boot on it. Okay, which will have. Oh, okay. Power button up here. So instead of this one, where it's right here, it's actually up here. And then we have our min-max, relative hold, range, and auto. So you can go auto manual on this one too. And this one will have the 4 jacks instead of the 3. So you have your 10 amp and your milliamp range. Okay, this one's Cat 3 at 1000, Cat 4 at 600 volts, and it's 10,000 count. Okay, just see if I can take this off down here at the bottom. It's kind of like your cell phone, it holds in there pretty snug. Okay, there we go. Yeah, it's funny how this silicon case adds a little bit of weight. It doesn't, by themselves they don't feel heavy. Together it just feels more substantial. And this guy, I can see, you know, the plastic fill just makes it feel lighter. But yeah, it's kind of interesting how it's almost a psychological effect. Having that rubber case just makes it feel a little heavier, which it is a little bit, of course. Now look at this. I thought this was interesting. I thought, wow, does it take 6 batteries? No, they just gave you an extra set. That was kind of interesting. And you know, the nice thing about this case, it has a pouch, and then it has the band that holds your meter in. And by the way, when you put your meter in, just put it face down, so it protects it from getting scratched, right? So we're going to put batteries in this. There's your temperature probe. Okay, we're going to put batteries in these and check them out. You know, I do want to mention that the manuals are actually pretty substantial. They did a really nice job covering the meter and stuff. So pretty, you know, the English in them, I mean, see, it's July 21. The English in them is good. It's, yeah, they're well written, nice manuals. Alright, just wanted to show you, there is a PEM in here, so it's a nice, you know, it's the kind of screws we're used to for battery compartments. There's a little bit of a lip, not super deep, but it's pretty large, and the battery compartment's totally sealed from the meter, so that's a nice touch. So you don't have to worry about batteries leaking into your circuit board and that kind of thing. And also, as far as protection, you know, the meter's protected from, you know, so if something were to happen, it's not going to come out the battery compartment anyway because it's all sealed up. Alright, I just decided to take it apart since these 2 screws are underneath the battery compartment door, so instead of having to take it all apart again, I just decided to take them out and show you the insides now if I can figure out how to open it. Okay, I see there's a little tab right here that was holding the board. Alright, you may have noticed how snug that was. It wasn't super simple to take out. First of all, I'm noticing how the contacts are. I like this, so there's no wires. I'm always afraid to pull away and break wires off of the board, but okay, there's this. See all the ribbing? The other thing I'm looking at is how the buttons are put in. See how there's plenty of flashing, or you know, they're much larger than the hole size, so everything's sealed well. I don't see, I mean, this back of the case is very rigid. Alright, and it looks like we have 2 ceramic fuses. I wouldn't say they're high rupture capacity, at least there's nothing saying they are, but the board is a 2-layer, there's a 2-system board technique in here, which I think that's interesting. So the fuse and everything is all, and the protection is all on one board, and the digital electronics is on another board, so that's actually a nice touch, I think. Alright guys, just bring this a little closer so you can see the 2 battery contacts. Look at these networks of resistors. Like here's some big, large, maybe half watt, 1 watt resistors. There's a series of resistors there, a bank of them here, another bank, lots of resistors. Alright guys, so the power comes up to the board here. Look at that, there's a, it looks like a sense resistor, a 5 milliohm resistor, and there's a MELF resistor. Here's a series of diodes for protection, I'm sure. dial network. Here's your relay. So that's how it does all the switching, and a bunch of transistors here, a larger transistor. There's your 8 megahertz crystal with this chip. You can read that chip. So here's a relay and the diode network protection, all the transistors. Look at this. This is impressive. There's a tantalum capacitor, another tantalum capacitors. Tantalum capacitors are not inexpensive. There's a large inductor, so that must be some power supply here, probably to power the LED. Then we have another chip over here. Looks like it's a lot of these lines are coming over here, this network over here, and I don't know. A lot of stuff going on. That's probably for the display, I'm guessing. Now, here's an interesting thing. That's an actual mechanical switch. Touch on off. So I like that because that means you physically break the battery connection and it's not just a soft switch. And then here's your non-contact voltage antenna. So I like where it shows where it actually is, so you know where to aim the darn thing. And yeah, like I say, the buttons, you know, very nice, you know, switches on the sides here. I mean, it's all nice that they're actual mechanical switches, I think. That looks like it's a SD8107 or something like that. So, you guys tell me what that is. Is that a MUX maybe? I don't know. One thing I want to point out is that right there, that 94V0, that's your fire rating. That's a UL thing. You can see the UL insignia down there. Okay guys, so I hope you don't blame me for not taking it apart any further, but there's a bunch of screws along in here. You can see these little features here that help, these little features here help place the board in so before they put the screws in. So there's another one right over here. But yeah, there's a bunch of screws in this thing and a bunch of screws down here and the buttons on the side. I just don't want to take it apart because I think everything we're looking at is, or we're interested in, we can see right here. See the little plastic guide here? That's to keep the voltage separation from the fuse to this network of resistors. Same thing over here on this side. So I want to point out one other feature. See the silicone here on this button on both sides? The little feature drops down inside here. So it seals off this compartment where the button is, where we're pressing, so that stuff, contaminants or whatever, doesn't get from the outside case inside. And it's a nice way to control where the switch is and all that stuff. So yeah, I think it's nicely done. And if you want to take a look at the solder joints down here below, see how these are split? So it looks like they might be sensing where the lead, if the lead's put in place or not. On this side they're not. Over here they're split, so it looks like they're sensing if the lead's in place. So yeah, I mean, this is amazing construction for a meter at this price point. So as far as plastic shielding goes, the whole back of the case is basically double layer plastic, because you have the whole plastic piece you snap on, then you got this battery compartment that's almost a full back. And then even after that, oh, look at that display, it's on. Then even after that, it goes into this silicone case, which, oops, by the way, you want to snap these buttons in first, right? There we go. And then push down the bottom. There we go. Ah, nice. Wow, look at that display. That looks like a nice display. Yeah, sorry about all the glare with all my lights and all the stuff in here. It's kind of hard to find a place where we don't have some kind of reflection. But wow, that's cool, the colors, right? Sorry about all the reflections, guys. But here, let me just show you this thing when you power it up. It goes through a bunch of series of checks. It turns on the LED. Whoops, you got to hold it down. And it turns on all these LEDs. You kind of see them flashing. It's like, oh, it's telling you to plug in here. Alright guys, there you go. Just zoomed in on this part of the display. So yeah, you got your volts AC or DC, ohms, then continuity, then your diode check, capacitor, then millivolts, AC DC, then hertz, duty cycle, temperature, and non-contact or live, milliamps and amps. So here, let's zoom out and let's go into manual range. Okay, you just hold down, there's DC. And there's ohms, mega ohms. There's ohms, maybe continuity. And there's volts, it looks like DC volts. Nanofarads. And you notice the temperatures up here, reading temperature in here. You can see it's kind of chilly where I am. There's millivolts, hertz. And up there it gave you duty cycle, by the way, if you notice that. Here's Celsius, Fahrenheit. There's non-contact voltage. And there's the lead for the live testing. Oh, that's for current, milliamps and amps. It's saying get the leads. See, it's flashing right here. Tell me where to put the lights. Tell me where to put the leads. Okay, right there it flashes, say go in volts. So when I move this, it's telling me which place to put this leads. And then this next one's current, milliamps. And there's the 10 amp setting. And then we're back to volts, ohms, and all that kind of stuff. Alright, it's kind of interesting. As soon as I put the leads in, I can hear the relay clicking back and forth. There it goes. You hear the relay? That's pretty fast, so it detects ohms. There you go. So now if you want to, if you know you're reading ohms, you can go to ohms so you don't have to wait for it to figure out what you're doing. And it has, the sound. It is a latching, and it does have a nice sound to it, I think. But yeah, there you go. So there's the continuity. So now so now if I go to manual and I just go to continuity, yep, much faster, right? Now if I go to diode, I'm just curious how many volts it reads on diode setting. I'll just stick these up here, see if I can make contact. Okay, 3.96 volts. That's going to turn on pretty much most LEDs, and yeah, that's nice. Almost 4 volts. That's pretty darn nice. All right, guys, I'm going to go through these LEDs real quick. There's a green 2.3, blue 2.5, red 1.8. And let's go to the white one at 2.6. So yeah, it does a great job. Let's see, there's a Schottky diode. Yep, that looks great. Okay, let's go to capacitors. Yeah, this guy will read up to 100,000 microfarads. That is impressive. Let's read this little cap here. Okay, 52 microfarads. It's a 47 microfarad cap, so that sounds right. Here, let's pull up a big one. This one is a 6800 microfarad. Make sure it's drained before we make contacts. Okay. Takes a little time. Okay, 6.3, and it's rated at 6.8, so that sounds probably right. Alright, guys, this is the non-contact or the live setting. So first we'll do the live, and I'll put it in the hot side here, and it says H for hot, and red LED up there. That's neutral, so it's not reading anything. Alright, so now let's just do the non-contact voltage setting. Okay, so for the non-contact voltage setting, let's see. First you get a green one. Yep, there we go. Alright guys, so this is the value of a 6,000 count meter. 6 volts we've got, or 6.8 volts, we still have 3 counts. Look at that. Now as we go up in voltage, we still have 3 counts after the decimal spot. Look at that. And then once you go over 10, now you're back down to 2. So that's a 10,000 count meter. That's the value of that. You go all the way to 10 volts before you drop a decimal point. Okay, now just a note on the hold function. When you hit hold, it just freezes the display. Okay, now if you go to min-max, now we're 11.9 volts or whatever. Okay, now I'll wiggle the voltage around. So it'll capture the highest voltage it sees. It'll continue to capture that. Now if I go down to min, it tells me the minimum voltage during that, the time when I hit this. So that's how that works. Okay, one thing I want to point out though is if you're in max and you're say 7.7 underneath that 10,000 count, but if you go over the 10,000 count, let's see what happens. It goes, oh well, you're out of range. So if you knew you're going to go above 10 volts and you wanted to capture that max, then what you want to do is turn this off first of all. Okay, go to manual range. See how you can manually range this? And move that decimal point over. Okay, now if you're down here around 7 volts, now you're there. Now if you go to max, now if you go over 10 volts, it's going to capture your highest reading, right? Now you go back to min and there's a minimum reading. Now just to show you this little power thing there, you want to turn off the auto power. Just do that, your auto power is turned off. So that's a nice easy way to do that. And then your flashlight on this side, can you see that? So there's your flashlight. Alright, and there's your AC readings. Your AC voltage tells you the hertz above. So as I change the frequency, you see that update. So yeah, pretty cool. I like having a dual display meter. Alright, let me see. I got this 3 screws out of this thing. And I'm going to take this one apart before you put battery. Well, I guess we got to take it apart and put the batteries in it, right? Oh, I guess the battery compartment is in the back. The guy was in the seam so tight that I couldn't even tell there was a separate compartment. Same kind of thing, sealed off from the board. There we go. Oh, see, this is the kind with the wires where you got to be careful you just don't yank. Alright, so yeah, you got to be careful with the wire kind. That's what I was looking for before. And there is some tape here. There's a little hole there where it's fed up, so to give some strain relief. And a screw right there too. That's nice. Polarity marking in case you do have to change that out for some reason. Looks like another relay, transistors, another PTC. This time only a single board. And look at the metal coming in off the bottom. Curves up the side and curves up this side. So they're totally separate from each other. So lots of voltage isolation. There's no current and there's no fusing. So it's intrinsically safe that way. Alright, and there are the parts. There's the glob top there and the other IC. One for the display, one for the multimeter functions. Some MELF resistors here, PTC, some transistors, a bunch more transistors, some more transistors up here. There's your buzzer, LED, and there's your antenna for the non-contact voltage, just using the edge of the board. And that looks like another inductor for probably a little power supply here for your processor chips. Even after taking out the screw, it does go into the pin, if you noticed that before. This line right here does kind of show a compartment, but man, it's in there so snug and tight, and the tolerances on this are so snug. Well, when I took the screw out, it didn't want to come apart, so I thought maybe, you know, that screw and these two screws took off the whole back, but yeah. So yeah, I couldn't tell if that was just a look-alike door, real thing, but it's a real thing. Okay, so here's a look at all the displays. I took the leads out so that it would stop trying to, so this one would stop trying to figure out what to read. And it's giving temperatures here. They're off by a degree. And this one doesn't have the temperature on it. You can see they're all searching, you know, looking around for, you know, where to go to. Okay, here's something that's kind of interesting. The leads on this one over here look like that, and the leads on this one over here, they look very similar. They are different, but they look very similar. Now this is the little cap, so if I take that off, they look very similar, right? Now here's the leads for this one in the middle. Kind of big, right? I mean, I don't mind them, but I almost kind of like them, actually. I got kind of big hands, I kind of like them. And big old caps on them, they hold real tight. They all have very sharp tips, yikes. Alright, so now I have the leads in that middle one. There we go. Now if I go to manual mode, or if I go to ohms, and I can go to continuity right there, okay? So it is latching and it is pretty loud, right? Different pitch and louder than this one. Alright, so now let's try this one. Whoops. Sounds more like the one over here, I think. Yeah, sounds the same. So the one in the middle, louder and different tone. Alright guys, so they're off a little bit from each other. These two are really close. Now it's about 0.5% tolerance on DC with 3 digits. So the last one can be 3 digits plus minus, and you know, that 0.5%, which is pretty typical of meters, like I said before. So what I want to show you is 4,000 count, 6,000 count, 10,000 count. When we see 4,000 counts on this, you know, over 4 volts, it's going to lose a decimal spot. Yep, see what I mean? Okay, now if we go over 6,000, we're going to lose one here. Alright, so we still have 3 decimal spots here, and again, I've already shown that, but once you go over 10, okay, so that's, then once you're over 10, they're all the same, so there's no, you know, then it doesn't matter. But now once we go up to, say, if we could go, I don't have, my power supply won't go over 40 volts, but if I could go over 40, then we could see it drop again. Alright guys, I put them all on non-contact voltage setting. This one's the only one that actually says on the display. There we go. It starts with the green, then goes to red. There we go, same thing. Yeah, they kind of start off with the green and then they go red. Alright, so I put this in diode function, and let's read the diode voltage. Wow, that was fast, 1.8 volts. So that's not going to turn on as many LEDs, right? No, for that one, nope. Okay, I see a little dim red, but no voltage telling. This white one's not going to happen. Let's try this yellow one. I always forget which side's which. I don't see it turning on. Yeah, so yeah, not very good on the LEDs, but we get carried away with LEDs sometimes. It is a diode function on an LED tester, so it does do Shockeys great. Let's check the live function on it. Got it set in live. Yep, works there. Okay, I got a 1 millifarad, 1000 microfarad cap here. It's supposed to go up to 4 millifarad, so not as big a range as the other ones, but let's try it out. Okay, let's try that out on this cap. Yep. Alright, so let's take a look at the backlight here. That's nice, evenly lit backlight. Okay, let's turn on the flashlight. Well, that's with the backlight on. And there we are. Wonder if it's brighter if I turn off one of them. It might have been, I'm not sure. But anyway, that's the flashlight. Let's turn that off. One thing I want to point out is they all do have that bar graph, if you notice. This one's down here, this one's up here, this one's down here. I'm just wiggling around voltages, messing around so you can kind of watch them all jump around. Alright guys, so what do you think of these meters? The new 10,000 count or the new 4,000 count? Or you're going to stick with the 6,000 count? I like this meter because it takes the full size test leads and 10,000 counts. I like that. So I like the way it shows the where you put the probes. I think that's kind of a cool thing too. And for, gosh, it's definitely under 40 bucks. It's in the $35 range, something like that. But let me know what you guys think. This is just a quick, wasn't a full review of course, but I hope it was enough to give you an idea what the meters look like, what they can do, and let me know what you think. Thanks for watching, guys. Thanks for Patreons, and thanks to Kaiweets for sending these. And I'm going to try to find, I've got this brand new box unopened, so yeah, we'll find a home for this one, and yeah, maybe some more, I don't know. I've got some tools, I've got some more, I've got other meters, and a bunch more reviews I'm going to try to pile in the next short while, so I can kind of catch up with my meter reviews for the holidays. And yeah, thanks guys. Let me know what you guys think of these reviews. I hate to spend a long time, but you know, and I don't think it's very valuable to read, you know, 20 different resistors, 20 different voltages and stuff like that. But let me know what you guys think. Thanks for watching. We'll see you next time.